Hi, this starts our lectures on Chapter 1. This is Section 1.1. We're going to be discussing the concepts of variables and constants and describing a procedure or concept using algebraic modeling. The first thing we need to talk about is this area right here. We are going to be talking about a variable or a constant in a little bit. First of all, a variable is a variable quantity, exactly what it says it is. It is a quantity that does not stay one particular item. In algebra, we name unknown quantities or variable quantities using a letter from our alphabet and sometimes the Greek alphabet. The most popular and widely used are X and N. I'm more partial to X than I am to N, but you can use any letter that seems to represent best the situation that you're trying to describe. I try to stay away from S's and T's because they look like pluses and fives, respectively. So what we want to understand is that you can have that choice, and that choice does sometimes reflect the circumstance. Now, when we do represent a variable, we want to make it clear to our reader so that our reader has a roadmap, if you will, of what's going on when we say, okay, well, this letter represents this thing. And that's what I call setup. So setup is a very important thing in my mind. So setup here is what we want to talk about. There's that writing thing that I described to you. I'm going to close my notebook here really quickly and then reopen it because, like I said, I'm having a hard time with that. So anyway, our setup in this particular instance for this problem down here, the example number 1, I'm going to call it, we're going to go through this. So in this point it says, I want to describe the temperature in an oven as it heats to cooking temperature for cookies. Describe the situation using a variable, and don't forget the units. Now, units are the quantity that the variable's numbers represent, and that is important. So I'm going to write here temperature, and oops, for some reason I'm not getting a writing there. Okay, temperature, and I'm just going to abbreviate that way, and I'm going to say this is an X, and I'm going to say degrees. Now, in most instances, we're going to use abbreviations such as the little circle to represent degrees, but in this instance I would write it out because the little circle up there doesn't seem to do as quite as what we want it to. And so that is how we would represent a variable. And then the next thing that we want to do is we want to go ahead and we'd want to talk about a constant. A constant, unlike a variable, remains constant throughout time. So we have numbers that don't change in many instances combined with numbers that will change. So our next example here is one that deals with a constant as well as several variable conditions. And you'll notice that in this one, units are given in each case as well. So I want my garden to be 9 square meters, but I'm undecided on the length in meters and the width in meters of my garden. The area of the rectangle is the length times the width. You'll eventually need to know that. We haven't set that up yet, but I will soon be doing that. Give the setup for this scenario listing all the important information such as the variables, the constants, how the variables and the constants interact, and the units that are involved. So I'm going to set here and we're going to do our example 2. And so on this one, what we have is we have the area of a garden. And so we're going to represent that as we do with all areas. We use a capital A for area in math. And the area is going to be equal to something as well. Now we need two variables in this as well. And this is the length of this garden, and we need the width of this garden. And so I'm going to define those as we usually do as well with L and a W. Now the area in this is equal to 9, and we're going to use meters squared here. And so you notice that's how we get the units in there. Now the area we're also told is equal to the length, times the width here. And our length, we're going to say in meters, and our width in meters as well. And that is going to define everything that we need to know in this problem. So this, the area, which is a